Good morning, class, and welcome to Chapter 1.5, Measurement, Uncertainty, Accuracy, and Precision. There are two kinds of measurements. There are exact measurements, which are measurements that have no uncertainty. For example, you can have a pile of coins, and you will know exactly how many coins you have, with no uncertainty at all. You could also have a handful of balloons, and you would know exactly how many balloons you have. In this case, we have 6. 2 yellow, 2 green, 1 blue, 1 red. There is no uncertainty in that. I could have a handful of candy. I could have 4 pieces of candy in my hand and know exactly how much candy I have. Finally, you could have a box of crayons, and if you open that box of crayons, you would know exactly how many crayons are in the box. There is no uncertainty in this measurement. All other measurements, whether you made them yourself or an instrument made them for you like a scale, have some uncertainty in them. All other measurements. So what we have here is sort of a close-up shot of a graduated cylinder with some liquid in it. And it looks like we've got two kind of hash marks in here. You've got the 20 milliliter line and then some smaller divisions, which are to the 1 milliliter. I want to know which of the following values are correct. Do you have 20 milliliters of liquid? Is it 21? Is it 21.4? 21.5? Or could we go really crazy and measure to the hundredths place? Or maybe go really wild and measure to the 10,000th place? How do we know? Well, there is a rule of thumb, and the rule of thumb states that you can go to one place beyond your most sensitive tick mark. In this case, our most sensitive tick mark is the 1 milliliter. So we can go one place beyond that, which would be to the 10th of a milliliter. So in this case, reasonable estimates would be 21.5, 21.4, and 21.6 milliliters. Notice the difference in those three measurements. Any one of those could be correct. We have some estimation in there. All of the digits in that measurement, including the estimated digit, are considered significant or important to your measurement. But what about when you have zeros in your measurement? So for example, I have a question. How far is it from New York City to LA? If the answer given to me is 2,800 miles, is that an entirely measured value or is that an estimated value, and how do I know? So the actual distance, depending on the address, from New York City to LA is 2,797.0 miles. This is a true measured distance. And so all of the digits in this measurement are significant or important. That means since there are 5 measured digits, there are 5 significant figures in this measurement. So maybe now we can see that 2,800 is not a measured value, but more of an estimated value or a rounded value from a previous number. So in this case, there are only 2 significant digits. But how did I know that without somebody telling me in advance that that was rounded? Well, for the sake of consistency, we've come up with some rules to help you determine when a zero is a placeholder and when it is an actual measured number. Okay, so 2 ways to tell. So first, there are 3 kinds of zeros out there. 3 kinds of zeros that there are possible to have. The first kind of zero is a zero that occurs in the middle of a number. We call this a sandwich or a captive zero. Sandwich or captive zeros, zeros that occur in the middle of a number, are never placeholders. They are always measured and they always count, meaning they're significant, they're important. So here in this number, we have several captive zeros in here, and I want you to know that those are all significant. They all count towards your measurement. So once again, sandwich zeros are always significant, always count. Our second kind of zero are zeros at the beginning of a number. So we call these leading zeros. You can think of these like the first train, the first car in a series of trains, like the one that the engineer drives. So these are your leading zeros. Any zero that starts off a number is not significant. Never, ever, ever. It is always a placeholder, so it doesn't count. So if you look at this first measurement, that first zero is a placeholder. It doesn't count. So you have 3 significant figures. In the second measure, neither of those zeros count, and you have 2 significant figures. And the third measurement, none of those zeros count, and so you only have 3 significant digits. So again, leading zeros are never significant and they don't count. They're always just considered placeholders. Maybe you've guessed by now, but the third kind of zero are zeros at the end of a number. We call these trailing zeros. Think of them like the caboose at the end of the train. Okay? Unlike the first two, trailing zeros, it depends. And what does it depend on? Well, it depends on whether or not there's a decimal point in the number. If you have a decimal point, they count. No decimal point, they don't count. So if you look at that first number, there is no decimal point, so none of those zeros are significant. So you only have one significant number in that measurement, that's the 1. In this second number with the same amount of zeros, but there is a decimal point. So all 4 of those zeros count, and you now have 5 significant figures. In the third measurement, again, you have a decimal point, so all of those zeros are trailing zeros, and they all count. So once again, you have 5 significant figures. So again, they count if there is a decimal point, and it doesn't matter where the decimal point is, so long as you have one. Okay, so what happens when you have multiple instruments with different levels of significance, and you're adding or subtracting, multiplying, dividing, or just basically doing some sort of math with them? How do we know what to report? So for example, you want to know how efficient your car is. So you fill up your gas tank with 11.998 gallons of gas according to the pump, and then proceed to drive 383.9 miles according to the odometer in your car before you run out of gas. We want to know the efficiency, which is measured in miles per gallon. So if you type this into your calculator, your 383.9 miles, and divide those by your gallons of gas, you will get the efficiency. But how do we know what our actual answer should be? So if you look at this first number, you've got what to the 10th place. If you look at your gallons of gas, the pump reported that to the thousandth of a gallon. So how do you know what your answer should be? Well, if you just type it into your calculator is going to give you a really long number with a lot of decimal places. And most of us would not report such a number. For instance, you would never say that your car got 31.9969995 miles per gallon, right? You wouldn't say that. You wouldn't say 31.996999995 miles per gallon. What would you say? Well, you would probably round that to 32, but there is an actual set of rules, which says that your final calculated value, which is a measurement, can only be as precise as your least precise measurement. So again, for the sake of consistency, we have a set of rules to help you determine where to round and how many significant figures to report when performing your calculations. Rule 1 deals with multiplication and division. When multiplying or dividing numbers, you always want to round your answer and report it to the one with the fewest number of sig figs. So again, your answer should be rounded to have the same number of significant figures as your measurement with the fewest. If we go back to our original example, okay, we had two measurements, 383.9 and 11.998. The first measurement had 4 significant figures. The second measurement had 5. Our calculator gave us an answer with 9 significant figures. Well, we clearly don't want to report 9. Instead, we want to report the same amount as the fewest. Well, 4 and 5, the fewest is 4. So we have to round our calculator answer to give us 4 significant figures. So you might want to, at this point, see if you can figure out what the answer should be. Here's our number that our calculator gave us. We want 4 significant figures. The first 4 significant figures are the 3, the 1, the 9, and the 9. Immediately after the 9, we have a 6, which is more than 5. That is going to cause that 9 to round up, which is going to cause the next 9 to round up, which is going to cause the 1 to round up. So our final answer is going to be 32.00 miles per gallon. Again, we want 4 significant figures in our answer. And that decimal point there makes those last 2 zeros significant. Keep in mind, you don't want fewer significant answers than you should have. Rule number 2 deals with addition and subtraction. When dealing with addition and subtraction, you don't have to count significant figures. Instead, you're going to go with the least number of decimal places. Least number of decimal places, which is a little bit easier, I think, than dealing with multiplication and division. So, example, I'm measuring the distance from my house to Georgia Highlands College. The first thing I do is measure from my house to the end of the driveway, or my carport. When doing this, I discover that my driveway is 45.72 meters long. Wow, that's a long driveway. At any rate, I then measure the second leg of the journey from the end of my driveway to the school as 17,702.7 meters. Since I want to know the total distance from my home to the school, I'm going to add those two values together. So 45.72 plus 17,702.7, put that into my calculator, and I'm going to get a value of 17,748.42 meters. Now, my rules for significant figures say that when I'm adding and subtracting, I can only have to the least number of decimal places. So again, I'm going to have to round here. The least number of decimal places was given to me by my odometer. That's 1 decimal place. So if I round this value to 1 decimal place, I'm going to draw my line between the first decimal place and the last. I see that that is a 2. That 2 means that I am not going to round my 4 up, and my final answer is going to be 17,748.4. The last thing we're going to talk about is accuracy versus precision. Accuracy is a measure of how close to the true value that you are. So if you know water boils at 100 degrees and you measure it using a thermometer at 100.2, you're pretty good. Precision is a measure of how close your values are to each other. So if you measure the boiling point of water 10 times and all of your values come out close to each other, then those values are precise. So we're going to have a picture coming up here of precise, right? Precise. The dots are close to each other. And now